Okay, I'm going to take you through lesson 8.5, example 2, the example 2 and try it, and also the example 3 and try it. All right, you have a dot plot here that shows Anne's science quiz scores. How can Anne determine the variability in her science quiz scores? Okay, so what you're going to have to figure out how to do is, well, first, how do you interpret this dot plot? This means that she got 178, 379s, 180, 181, 282s, and 184. Did she have any 83s? No, she did not. In order to figure out the variability here, they're asking you to figure out the interquartile range, or the IQR. That is part of the box and whisker plot. Okay, so you need to take these scores and figure out what your box plot would look like. Okay, and more importantly, what your first quartile would be and your third quartile. Okay, the interquartile range, or the IQR, is a measure of variability. Okay, just like the MAD, that's a measure of variability in the data. Okay, it represents the difference between the third quartile range and the first quartile range. Okay, so you're going to have to subtract the first quartile from the second quartile. Okay. Okay, so so here's your example. So if you were trying to figure out what your box and whisker plot would look like, you'd have to figure out your mean. You'd have to figure out your minimum, your maximum, your first quartile, and your second quartile. All right. Why don't you pause the video and go ahead and figure out all of that information. Okay, you should have figured out more. The most important part here, the first quartile and the third quartile. The first quartile should have been 79. Okay, that was the mean in the first half of your data. And your third quartile should have been 82. That was the last half. That was the mean of the last half of her scores. Okay. So in order to figure out the IQR, or the interquartile range, you have to subtract those amounts. So you take 82 minus 79. Okay. Look at the next example, but try it. Here you're asked to do the same thing. You want to figure out, first of all, what your data is. You're going to have 184, 186, 188, 190, 292s, and 194. First thing you need to figure out is the information for your box and whisker plot, or your box plot. The part of the box plot that shows the IQR, or the interquartile range, is the box. It's the first part of the box compared to the very last part of the box. Okay. So let me give you a visual here. So if this was your number line, and here's your box. Remember, in here, this is the mark for your mean. Your whiskers indicate your minimum and maximum. So we are looking at the first quartile right here. What is this number on? And the third quartile. What number is that on the number line? Okay. And now you're going to take this number, you're going to take the first quartile and find the difference between that and the third quartile. So you're going to take the bigger number minus the smaller number. So you're going to take the third quartile minus the first quartile. Go ahead and pause the video and go ahead and figure out that information. Okay, you should have found that the IQR here would have been 6. Okay, at least half of Anne's scores are within 6 points of the mean. Is what exactly you're finding out. Okay, don't worry about all the meanings. We'll just discuss that tomorrow. Okay. Okay, example 3. So here you're trying to find the IQR for the variability. How can the IQR describe her scores? The IQR means that all of her scores fall within 6 of the mean. Okay. Or they all fall within 6 points. Okay. There's only a difference of 6 points.
Jonah recorded the points his team scored during its last 9 basketball games. The mean number of points scored was 42, and the MAD was 4.4 repeating. How can Jonah use these measures to describe the variability of the points his team scored during the last 9 games?
Okay, if the MAD was 2.4, then how would you expect the data distribution to change? The data points would be closer together. The bigger the MAD is, the more spread out your points are. The more spread out your data is. The smaller the MAD, the closer all of your points would be. Okay. Let's look at the try it. Okay, so here are Jonah's team scores: 36, 37, 38, 38, 41, 46, 47, 47, and 48. They want you to find the IQR, or the interquartile range, of the points Jonah's team scored in the last 9 games. Are these good measures for describing the points scored? All right, so you're going to have to figure out what would be the first quartile in your box plot, what would be the third quartile in your box plot, and find the difference. Okay, go ahead and do that. Okay, you should have found that the IQR, the interquartile range, was 9.5. The third quartile was 47, and the first quartile was 37.5. The difference was 9.5. The range of the scores, 48 minus 36, that's the biggest score, minus the smallest score, was 12. So that means that the IQR and the range are close in value. So that shows about half of the data is clustered at each end. These are good measures for describing the points scored. So that means that the box in the box and whisker plot has a very large distribution of numbers inside of it. Okay, so for the most part, most of the numbers are within the box of the box plot. The whiskers to your box plot should not take up that much space. Okay, so we'll talk more about interquartile range and what exactly all of this means and MAD tomorrow. Your homework is going to be to finish up page 484 that we started yesterday.